Alright, here's another inequality that we can graph. Now, it's only one variable, and normally when we graph like one variable inequalities, we graph it with one line, alright, and that works because like if I were to graph x is greater than 4, I could graph it like this, where it's all the coordinates to the right of 4 on a number line. Alright, the same idea here, except now we have two dimensions we have to graph in, x and y. So just like last time, we're going to graph the line x equals 4, but since it's greater than, we're going to give it a dotted line. Alright, so this right here would be the line x equals 4. Now to graph all the points where x is greater than 4, we're going to shade to the right, because that's where x is greater than 4. All these points here have x coordinates that are greater than 4. It doesn't matter what y is, which is why it's a vertical line and we graph like all the way up and down, but that's all you got to do for a one variable equation, just graph a horizontal or vertical line. And again, dotted line here because it's a greater than symbol. Alright, so now when we sketch, just a quick recap of when we sketch an inequality with two variables, we're going to first just graph it like it's an equal, like it's an equation. So replace the inequality sign with an equal sign, and then sketch the graph of the equation. Use a dash line for greater than or less than, because any point on that dash line is not going to be a solution if it's a greater than or less than symbol. It's not going to be a solution of the inequality. But for a greater than or equal to or less than or equal to, then that means all the points on the equation's graph are part of the solution. So that's why we give it a solid line. Then we just test the point in one of the regions, and if one point in that region works, then you shade that entire region. If it doesn't, then the other region has to be the solution. So the graph will always divide the coordinate plane into two parts. Right, so here's one that I did on my calculator, just to kind of save time here, and I'll show you how you could type this in on a TI Inspire. But this is a system of inequalities, because you have three equations here, three inequalities that we have to graph. So the first one would be x minus y is less than 2. So if I was graphing that, I would write it as an equation. So like x minus 2 is equal to y. So that would have a slope of 1, y-intercept of negative 2. And I would graph it with a dotted line because it's a greater than sign. So it would look like this. And then I would test the point. Now when you test the point, you could test it in the original. So we'll plug in something like 0, 0, and 0 minus 0 is less than 2, so it works. So we would shade everything in this part of the graph, where the 0, 0 is on that side of the line. Okay, and then we do the same thing for the other lines. So x is greater than negative 2. Alright, that's also going to be a dotted line. X equals 2 is a vertical line. So we're going to draw a vertical dotted line and then shade to the right, because that's where all the points are, where x is greater than negative 2. Right, you can also test the point that way. Alright, and then the last one is y is less than or equal to 3. So that's going to get a solid line because it's less than or equal to, and all the points where y is less than 3 will be below that line. So when you're asked to find the solution to a system of inequalities, you want to find all the points that make that all of these inequalities true. So this inequality, that inequality, and that inequality. All right, and that's going to be the region that's shaded 3 times. All right, that means that all these points that I'm highlighting in green satisfy all 3 inequalities. So that would be your solution, and the only way to represent it is with a picture. Alright, these points are important here, these vertices, because they're kind of like the limits on where your graph, like where it ends to be like a solution and not a solution. So when it asks to find the vertices, you're really finding the system of equations, the solution to the systems of like each two equations. So like where this equation and this equation meet, it's at 5, 3. That's also the solution to the system of this equation and that equation if we were to write them with equal signs.